Okay, so in the previous video, I talked about the logic of Ramsey's regression specification error test. In this video, I'm going to show you an example of how to use this test in R. And in this example, I'm going to use this house price data that we saw earlier. In this first model, I'm going to regress this model of house prices on different explanatory variables in the level form. As I said in my previous video, I'm going to regress this model and get fitted values of these y variable, that is the fitted values of this price, and in the next step I'm going to plug those fitted values in the regression model. So this is exactly what I'm doing in the next step. I'm including these fitted values in the square term and in the cubic term in the regression model. So let's go ahead and estimate the model, and remember now these square and cubic terms include these higher order terms of all these x variables. So let's do that, and now all we have to do is to test whether these coefficient values for the fitted values in the square term and the fitted values in the cubic term are statistically significant or not jointly. So let's go ahead and test for the joint statistical significance of these two variables using the f-test. So looking at the f-test, the f value is about 4.67 and the p-value is about 0.01. So we are rejecting our null hypothesis at about 1% and conclude that there is misspecification of functional form in this regression model. An easier way of doing this is to regress our original model and use this function reset test and pass our original model to this function, and this function will give you exactly the same results as you getting the fitted values and then plugging in those fitted values in a regression model and then testing for the joint significance of those fitted values. And as you can see, we are getting the same p-value. So we can imagine that under the hood, this function is following the same procedure. Using this function, we can avoid these extra steps and simply apply this function and reach at the same conclusions. Okay, so we know that there is misspecification in this model. So let's try the log-log model and take the log of all the variables where the log can be taken. So let's regress this model in the log-log form and then apply this function reset test on this model and see our p-value of this f-test is 0.08, which means we are rejecting this null hypothesis only at 8%. So there is kind of weak evidence for misspecification here, and based on the reset test, the log-log model is preferred because there is less functional form misspecification in this log form as compared with the level model. So this is how you use Ramsey's regression specification error test to test for functional form misspecification of a regression model. Alright, I'll see you in the next video. Bye-bye.